So everything that I do is open source. Everything I'll talk about is open source. So the website to go to is ontologyportal.org, where you can also get copies of my book if you don't feel like buying one tonight. I will use the clicker. So for those people that may have seen a talk in the past, although I'm not sure any one of you may have seen any one of my talks, I figured I'd start with a punchline up front. Current applications, things that I'm doing that's recent in the past couple of years. Because I've been doing work on SUMO for about 10 years now. And then we'll get through as much of the outline as we possibly can, but feel free to ask questions. I'm happy to have this take a long time and not move just from slide to slide, but really have some good discussion as we go forward. So what am I doing now? So it's kind of a technology map. Why is this actually relevant to a commercial organization? The ontology has been very much just pure research for quite a long time. But now I found a company that's actually willing to pay to do this stuff and believes that it's going to really have an impact on their business. And so my goal is to apply ontology wherever I can to actually save them money or help them make money in different ways. So the first easiest application is just in structuring databases. Ontology gives you a way to define the meaning of various kinds of information in a way that's a lot, I believe, more robust from a semantic point of view than simply creating fields in a database with names and relations and maybe a little data dictionary. I think we can do much better. And so by extending SUMO, the suggested upper merged ontology, which I'll be talking about in considerable detail, I believe we can do a better job of organizing our information. And Reardon Commerce, the folks that I work for now since April, have a very massive database that has something like 18,000 different fields in it. A lot of it's historical, a lot of it's not necessarily consistent. It's siloed from different business units that have evolved over time. Partners of people have been acquired. We've gone into business with many partners, and harmonizing this massive data with a clear, explicit, formal semantics is a really big problem, and it's a problem on which ontology can help, and I'll try to give you some detail on that. We're also doing a big push in analytics, so something that's, I'm sure, near and dear to the heart of everybody that's here for a data mining group. And it's my contention that getting clear about the semantics of the data that you do expect to do data mining on is a really key enabler for doing proper analytics. Make sure you know what things mean before you try to expose the patterns in that data so that you really know what you're getting and you know what data can be combined with other data in a meaningful way. Capturing knowledge is a very important thing. There's a massive amount of knowledge at the company I work for in terms of travel, because that's what we do, corporate travel. And SUMO gives them a way to make explicit all of the rules and policies and business constraints that for the moment are fairly implicit or just on a wiki in text somewhere. We can do better. And lastly, inference. A lot of the more forward-looking research that I've been doing, especially for the US government over the past 10 years, has been focused more on decision support applications, trying to create rules about a particular domain, usually in the past a military domain, now in a travel domain, that captures expert knowledge, what used to be called expert systems, but I think now considerably more principled, more formal, more backed up by the mathematics of formal logic, and capturing that information and then doing inference, being able to ask questions. But instead of asking questions and getting a web page back where maybe the answer lies, or maybe getting thousands of web pages back where you hope the answer is there and a human being has to read those web pages, we'd like more of a model where that's like a database, where you issue a query and you get back an answer, you get back a match, you get back a solution for your query that hopefully is your answer. And to be able to do this through formal logic, through deduction, through deductive reasoning. So a little more detail on database structure. So here's an utterly trivial example. And I think one of the challenges in explaining ontology, in fact, I had a paper years ago that I submitted to a conference. It was on semiotics, on signs and symbols, and how to create a logic of signs and symbols. And one of the reviewer comments I got back is, your paper is a collection of trivial assertions about things in the world. And well, this fellow was absolutely right, because in fact, creating a large formal ontology does consist of a lot of trivial assertions about the world, things that people already know. But the fact is the computers don't know them. And so we have to make massive amounts of trivial assertions about the world to start giving computers some of the same reference points and rules about the behavior of our world so that computers don't do stupid things. They don't do things that are inconsistent with the facts that we know to be true about our world. So, okay, that's a long preamble for this little example. So here's just a couple of data points here. So we have a lot of information about hotel amenities, things that might exist in a hotel room that you're going to reserve for whatever purpose, business or pleasure. And even things as simple as, what's the power source? What are your plugs serving up, 120 volt or 220 volt? And we get lots of different feeds from different sources. Orbitz is one, North Star is another, and there are many other partners. And a lot of these feeds have similar information. They cover the same semantic space. They're concerned with hotels or flights or cars, but they haven't worked together. They haven't spent any time to harmonize the way in which they refer to things or define explicitly what are the boundaries between those different things and defining what they really mean. And so part of our job has been to go through these feeds, these data sources, and define very precisely in mathematics what do they actually mean. Give them a consistent label and then a consistent formal definition that can be checked with consistency automatically with respect to the rest of the definitions that we have. So even something very simple like this, of just specifying, how are we going to refer to the different power sources that might appear in a hotel room so you can plug in your laptop or your shaver or your hairdryer or what have you. So SUMO becomes a metadata repository, a very formal metadata repository, one that can be checked automatically. It's mathematically consistent. So my goal, one consistent formal model for all of Reardon, and then the entire world beyond there. I think that basically everywhere we have software, everywhere we have a database, everywhere we refer to information in the world, we'd be better off if we actually defined it precisely and defined it in a way that was consistent with the way in which we refer to every other bit of information in the world. I mean, every software system has an ontology. Every database has an ontology, but in most cases it's not explicit, it's implicit. It's in the mind of the designer. We can do better than that. Another thing we've been doing is an initial pilot project on sentiment analysis. I don't claim to be in any way, shape, or form an expert on sentiment analysis. We did something really kind of dumb. We just do sort of a single word extraction thing of looking at adjectives that are either positive or negative. We got some work from the University of Pittsburgh. They've done some great work in this area. And so instead of grabbing their whole program, we just grabbed their sentiment list, which is based on WordNet. We already use WordNet. It was really easy. And so we did, I probably shouldn't have called it computational linguistics, but it is of a sort. We do concept extraction, which is a little more complicated, and I hope to get to some description of that, where we try to get SUMO terms, formal ontology terms, to extract from the text that we parse, and then be able to do some data mining, very lightweight data mining so far, to find out what are the patterns in the data that we find. And here we're looking at review data for the most part about hotels. So, Joe Smith writes a review. He says the bed was really comfortable, but the bar was really boring at the hotel, and we'd like to be able to get that information out automatically. And then if our traveler cares about a good night's sleep a lot, then we say this is a great hotel. And if he's a party animal and just wanted to hang out at the bar all night, we say, go over to the Hard Rock Cafe and don't stay at this hotel instead. So just a pilot, but even out of this pilot, we've, I think, been able to get some pretty encouraging results already. So a little more detail on sentiment finding. So we start with a large number of reviews. From those reviews, we do some simple word sense disambiguation to try to get clear on what are the actual concepts being talked about, not just the words. We cut down on things a little bit. We have a stop word list to pull out obvious things. Anybody that's done linguistics, this is pretty basic. We've got a word sentiment list that I already mentioned. We come up with some scores for individual sentences. We give you an overall score. And in parallel with that, from our word sense disambiguation, we can grab individual word senses. We have word senses mapped to formal ontology concepts. We can assert that the reviewer is talking about particular things in the real world, particular concepts, and then we can tag those concepts with a particular sentiment. So, for example, the guest rooms are somewhat shop-worn or shabby, and we can say that that's a negative review because we know that shabby and shop-worn are particular negative adjectives, and we can give them a score, and we can extract the SUMO concept of room from this particular sentence and give it a sentiment. And then if somebody's searching for a comfortable room, we know that from their profile, that's the most important thing to them, then we can assert, this may be not the ideal hotel for you.
What do you do with sarcastic or things that are negative, like this was not great?
Yeah.
The word not is very important there. You have great, which is a high.
Right. Yes. So I could talk about the endless numbers of things that we don't do properly, right, with our sentence analysis, with our natural language understanding. At the moment, it's just a pilot project. We know there are all sorts of things that we do that are dumb, and yet, because of the large volume of data, large volume is our friend, a lot of things like that fall out because some people are sarcastic, but really not a majority. Now, that said, things like negation that you mentioned are far more prevalent than just sarcasm in reviews. And so we actually do have some ideas about how to handle that and improve our scores. So I could talk about that in more detail, may not get to it in the presentation, but we could talk about that afterwards. Language is hard. Yeah, there's no easy road here. Yeah. So the sentiment list itself, as I say, was done at the University of Pittsburgh. So they hired lots of graduate students to go through all of the adjectives in the WordNet natural linguistic database, if you will. I'll talk about WordNet a little bit later if you're not already familiar with that. It's a pretty cool open source project, been around a very long time. And so they just had these students go through and score whether adjectives were positive or negative, and whether it was strongly so or weakly so. And then they did some cross correlations to try to eliminate subjectivity and variability with their scorers, but I think they did a reasonable job. We just adopted that list, and I gave them arbitrary scores. So I said strong was 5 and weak was 1. Might have tried other numbers. That'd be a good thing to see if that comes out better. We're working on doing some corpus evaluation of this method to quantify a little better how good a job it actually does. But so far, not bad is what I'd say, a B. Okay, analytics. Lots of things that we do here. I'm not in the analytics group. We have a separate analytics group, but they're, I think, doing some interesting things. And suffice to say that our effort to support analytics is making sure that all our databases are harmonized. So we've got all these different sources. How do we lump it all into one big store of data that we can do analytics on? That job, that data integration job, is definitely a job for ontology, and where we've had considerable success, I think. Other things that we thought of this little truthometer idea. So you can analyze the reviews and get scores and see if those scores either agree with ratings agencies, agree with the ratings that people themselves give their own reviews, because this is a fairly well-known psychological thing that most people will kind of grade in the middle given any arbitrary scale, but then there are always outliers. So then another thing that we found all too frequently is that self-reporting is really bad. In fact, there's a hotel in San Francisco that will remain nameless that in one of our feeds claims that it's simply near everything. So clearly there was some sort of survey that the feed provider sends out, and they say, self-report, check off the features that your hotel has. Is it near mountains and lakes and the ocean? And well, these folks just clearly checked all the available boxes, so they say San Francisco is near mountains. Well, there's Sutro Tower, I guess, but data quality is a real serious issue. And so another one of the benefits of doing this kind of analysis is we can actually see, what are the concepts that pop up in the reviews, and do they actually agree with the self-reporting? And if it doesn't agree, then we have a way to possibly discount all the self-reporting about other information at that hotel. We know it's not to be trusted. Okay, so that's kind of the application side of where we're going in terms of applying this stuff to make real money and not just do pure research. let me give sort of the top-down view of, from a science standpoint, what have we been doing recently. We've done a bit of work to integrate some very large fact bases. So there's some cool work that a fellow named Gerard de Mello and some of his colleagues from Germany did to pull in data from Wikipedia. So they parse Wikipedia's info box relations. I don't know if you've noticed those. There are these little boxes that are up and to the right on a lot of Wikipedia pages. It's kind of a folksonomy. People have casually agreed to use certain relations, but there's enough regularity in that if we go through all of those info box relations and define them precisely in terms of SUMO, and then do some lightweight linguistic processing on the contents, we can extract large numbers of facts out of Wikipedia. And so we have a fact base that's between 4 and 5 million different facts about our world. And now we're expanding that effort considerably. We started out with mappings for about 30 of those Wikipedia infobox relations, and there's about 1,000 of them. We're going to try to cover a large portion of that set of 1,000. And that should expand greatly the number of things, number of facts that we know about the real world in terms of Wikipedia. And of course, Wikipedia and its use of infoboxes is also growing fairly rapidly. So we see this as being a very cool, lightweight way to do some information extraction without having to solve a lot of the hard problems in natural language understanding, because we can just leverage all this volunteer effort that people already engage in structuring Wikipedia. We don't have to change their tags. We don't have to get them to adopt some specific markup. We're just using the markup they already have and just trying to structure it, capture it, and formalize it a bit more tightly. We've done lots of work on our tool set. So we have a whole development environment for SUMO. You can liken it to an IDE in terms of programming. And I'll talk about that in a little bit of detail. We have lots of new inference engines, some work in higher order logic. I'll tell you about what higher order logic is a little bit later in the presentation, and also a cool thing called relevance detection that's really revolutionized inference on large knowledge bases in the past few years. Okay, so that was the punchline up front. Now background and a little bit of science. Or maybe a little bit of philosophy. And what we were talking about before we started is, ontology could be considered applied philosophy. Now, guys, that people that have gotten degrees in philosophy, PhDs in philosophy, they don't just have to teach. They can actually work in a corporate environment and make money. Cool thing. So this is a fairly common diagram that appears in lots of different forms in philosophy and linguistics textbooks. So let me try to break it down. So we have things in the real world, like a particular orange, that typically are called reference in this scheme. We have names for things that exist in the world. In English, we have orange. We have many human natural languages that name an orange by a different phrase, keyword. And it's my contention that a lot of people that are doing ontology are kind of cheating. They're kind of working in this domain, in the domain of language, where a human being has an association between this symbol and a lot of knowledge about that symbol. But that knowledge still isn't being made explicit. We're just sort of cheating, relying on human intuition in structuring ontology. It's my contention that ontology work needs to be up here. We need some analog for thought, for human knowledge representation. We need to have something that's powerful enough so that we can actually capture the information about the real world that tells us as humans what is an orange? What is it related to? What is it like? What does it taste like? What is its behavior in different situations? All the things that we bring to bear in our human understanding of orange. Now, we're a long way away from getting sort of sensory representations of orange into the computer. Other people are working on that, but from a cognitive standpoint, this is what I want. Cognitive representation of orange. So, yeah. Yes.
The thing on the top, if you're not talking about a person, but you're talking about a computer, then what is the concept? Is that what you're doing, is making concepts to fit inside computers?
Yes, absolutely. We're trying to, well, I could make this more lofty than it should be, because it boils down to a simple matter of programming. We're not claiming any grand thing that the machine is self-aware, but some little portion of what people are able to do in terms of representing their world and reasoning about it. We're trying to do artificial intelligence. We're trying to capture human intelligence, human knowledge in a form that can exist in the machine and do useful things. And it may not be a perfect analog, but our success metric is, are we able to do useful things that has some sort of analogy to human thought or human reasoning? And logic certainly has that. Yes?
The world could be divided up into any number of ways. People do it for our purposes and from our history. So are you trying to reproduce that necessarily?
Well, let's see. So there's a couple of things that are, I think, kind of packed into your question there. So people do this in different ways, and there's more than one way to carve up the world. Absolutely. And so, occasionally I get accused of trying to create the one true ontology, and let me just say categorically that is not what I believe in here. I'm not trying to create the one right way to represent everything. I've created a way that I believe has been successful in representing everything that we've come across. Right? So there is more than one way to carve up the world. There's more than one way, especially to represent metaphysical items at the top of the hierarchy. And those are usually where the worst arguments are amongst ontologists, is the top 5 levels of the ontology. Does that answer your question? Now you're stuck. You're eating pizza, so we can come back. Maybe we should come back to it later. So if you'll permit me, I'll continue, and I'll leave you hanging. So imagine your view of the web. This is just another way to kind of look at the same issue. So this may be obvious to some people, but maybe it just sort of drives home that, so you as a human being, you read the stuff in white, and you can make these labels that are in red yourself. It's pretty obvious. You know Joe Smith is a Western name. This looks like a resume. You know about something about schools. You can guess where the education is. However, when a machine sees, and my apologies to anyone who actually reads Chinese, is something like this. It sees a meaningless collection of characters, right? It doesn't know what any of this stuff means. Now, we can write processes. There's more than one way to skin this cat, too, of course. We can try to create some structure, but fundamentally, the machine doesn't understand this content. A lot of people think XML is going to solve this problem. XML has been very useful in structuring information. So great, we can say, Joe Smith has a name, that's his name, and he's got a title, he's got a job function. What the machine sees is this meaningless collection of characters. So now the characters have some structure, but it doesn't know what any of these labels actually means. People are working on taxonomies of various sorts, business taxonomies, controlled vocabularies. This is very popular. Very useful too, but doesn't really solve the problem of semantics. So great, we can say that Joe Smith is a person is a mammal. What the machine sees is this. Now we have our meaningless collection of symbols in a little hierarchical structure. We can go a little farther than this. Look at what people on the semantic web are doing with their set of technologies, OWL and Sparkle and so forth. So we know we can define a little bit more that Joe Smith is a specific instance of a person, and that a person is a kind of mammal. And because, at least for the semantic web, there are standards and a little bit of formal logic behind it that specifies the model theory, the proof theory, all of these things that allow us, if we have a conforming application, conforming inference system, to make this deduction. So that if we know, and we've asserted on the semantic web that Joe Smith is a particular person is a mammal, that standard licenses this truth-preserving inference that Joe Smith is therefore also a particular instance of mammal. Now, same thing here, there's no magic. The machine just sees these meaningless collection of symbols, but because of this sort of parallel between the structures that we're able to state in OWL and given its proof theory, and given that a person would also be able to make this inference, there's a parallel behavior. And so, things can go into the black box, and when they come out of the black box, if you translate back from the meaningless symbols, as the machine does, from its binary coding to whatever labels you've put in, you get an answer that actually looks pretty reasonable. And you say, okay, well, it's doing something useful. It's doing something like what I as a human being would do. Now, the problem is, this is not very exciting, this little tiny inference here. And so you want to be able to do tons and tons of these sorts of things and a lot more complicated things and have a lot more knowledge that allows you to do an endless number of these inferences. And if you collect in enough of them, my contention is, then you get something that starts to look kind of maybe intelligent, or at the very least is doing a lot of useful things, useful practical things. So we don't really need to debate the philosophy about, oh, is the machine actually becoming self-aware? Or is this a plausible way to reach true human intelligence? That's a fun debate that we can have some other time. What I'm concerned about is, can I do something that kind of looks intelligent in very, very restricted ways and does something useful for us from a practical computer science standpoint? So the key things for me are, be able to state anything about our world that we might want to say. Have a language, a logical language that's expressive enough that it doesn't hold us back from saying things that you and I would want to say to each other in English or any other human natural language. And we also need to have stated lots of things. We can't just say, okay, we've created this beautiful logic and a lot of tools, and now populating it is a simple exercise left to the reader. We've got to actually spend a lot of time, and in my case it's been 10 years of solid effort, chasing funding, trying to manage people, get volunteer support, to accumulate a vast amount of these definitions about our real world that people can build on.
Somehow this sounds like psychotic.
Yes, well, and in fact, we worked together at one point, and so there is, the similarity is not accidental. But there are a number of differences. Of course, one being the open source nature of all of this. Everything is open source and has been so right from the beginning. A bit more focus on linguistics, I'd say. The complete set of mappings to WordNet has been a key feature for adoption of SUMO, especially in the linguistics community. Completely defined logic that's independent of the implementation. So, there's reasonably precise mathematics about what things mean independent of the code that we've written to do the inference. I could go on with a few more of these things, so there are some differences. Okay? So there are lots of different languages that people have invented over the years to try to solve this problem. And the problem, as I take it, is we've got human language. It's extremely expressive, but it's very informal. There's all sorts of problems like sarcasm, being one, that make natural language very hard for machines to handle. So what we want is something that has the expressivity of human language, but has a great deal of formality, so it's amenable to automated processing. And so where we've come to with SUO-KIF, which is the language we code in, it's sort of close up to higher logic. We've got some issues that Valeria and other people are helping me with, if you know her, who's in the audience. We hope to make it even better and get even more expressive logics, but there are some open issues there. So for any of the serious logicians in the audience, I could probably get into more detail about that maybe after the talk. I'll touch on it a little bit. But a key thing is that DAML oil was sort of the first incarnation of the semantic web languages. I was actually part of the first DARPA project that tried to create this, and there were so many people interested in description logic that I had to throw up my hands and walk away from that debate because I wasn't going to win in terms of having more expressive logics. But I'll talk a little bit in a moment about why I think that description logic, and specifically OWL, is really actually insufficient as a knowledge representation language. There's some very concrete examples that I'll show you that are common things that we want to say about our world that you can't say. You simply can't say them. Now this can be a hard thing for people to get their arms around. So I've had a lot of people argue with me about, what do you mean I can't say that? Of course I can. I'll just write it down in the language. Well, so imagine as an analogy, you're writing a Microsoft Word document, right? So Microsoft Word is not a formal language. It doesn't allow you to do any inference. I can write down everything that I want, but the machine doesn't understand the semantics, the meaning of what I'm getting to. So you can write a lot of things in comments in OWL, but it won't be able to, within the bounds of its inference capability that's licensed by the standard that defines it, you won't be able to actually do any inference with the knowledge that you have, if it's this expressive sort of knowledge, and I'll talk about these examples in a moment. So, semantic web languages are basically frame languages. Frames have been around in AI for a very long time, and they're basically like this. So object-oriented languages are also similar to frame languages. They have frames, slots, and values. So you have a class person. Classes can have instances. Those instances have relations that are defined on them from the class definition. And once you have an instance, then you can put values for those slots. So I could say, you know, Adam, the person, has a certain height and a certain occupation. There are various flavors of frame languages, some of which you can do things like talking about the cardinality, that a slot can only have one filler for a particular individual. OWL has this sort of very useful stuff. People got by on it for quite a long time. It's rather informal. And so here are all some of the restrictions. So whenever somebody's a big semantic web advocate, one of the first examples I give them is, okay, so how do you represent between? One thing is between two others. You only have binary relations in OWL. Try it. You can't do it, except by this little trick, by decomposing what is essentially, inherently, a ternary relation into a collection of binary relations. And it's pretty awkward. It looks awful, and therefore nobody does it. And so if you actually look on the semantic web, you won't find spatial betweenness out there. It can be done. Nobody does it. The language doesn't lend itself to this. So you have to reify or create named terms for these three sort of roles of the three betweenness objects, you know, between 1, between 2, between 3. You have to create an instance of the betweenness relation, call it betweenness 1, and then say we have A, B, and C that are in this binary relation to this phantom betweenness object.
By the way, something that's hidden under there is there's an or.
Of course, the problem is even worse than I'm making it out to be here.
Spatially,
Yeah, which one is which, right? Is the B the thing that's in between? So you've got this additional problem. And then if you want to reconstitute kind of the original statement, you've got to add more information. So it's just a very serious problem. Now, there aren't a huge number of ternary or higher arity relations in the real world that we've found, but there are a few, and they're really important. And if your language doesn't handle them, I would say that's a pretty serious gap. There are other gaps. You know, this one has at least a mathematical bypass to it. Nobody uses that bypass in practice, but at least you can argue that it's possible. This other one's a bit harder. So let's say that I want to say the opposite of something. I want to negate a statement. If I want to say Adam is not an accountant. Well, there's no negation, really, in description logic for a whole statement. You can fudge it by creating a negation of every possible relation, so I have not occupation. The problem comes when you have a whole statement that you want to make, not just one little isolated thing, but you know, Adam is not an accountant who likes to go and do accounting at the London School of Economics every Thursday. You want to negate all that. There simply is no logical way to do this in this description logic. The logic itself does not support it. These things are ubiquitous in the real world. We say a whole series of things are not true all the time in English sentences. There are many other problems. I don't have to go into all of them, although I could offline. Now, a key thing that proponents claim, if they're willing to admit the fact of these problems, is that, okay, well, sure, but I can say everything I want and inference in it really fast. And that's why I've put up with this restriction. I'll argue that one in a moment as well. So another problem in frames or slots relationships with description logic is that it gives sort of primacy to one thing. It says that I have a frame and it has slots that can be filled with something else. But in the real world, there are things that are related where one entity is not necessarily primary, right? So say Adam authors the book Ontology. Should I always have to talk about Adam being the author of Ontology, or should I be able to say, well, the book Ontology was authored by Adam, and talk about it in sort of a different emphasis? In description logic, you're forced to give one object emphasis, and that leads to another case of ugliness, which is of creating all the inverses of all these relations, something you see very commonly in semantic web ontologies. Quantification, another thing there's a restricted case of it in description logic. but there are lots of things you can't say. Here are a couple of examples. You don't have to read the logic, just read the English. So all farmers like tractors. Very different statement than some farmer exists who likes some tractor. You need these different kinds of quantification of saying for all or there exists one. You can say that in more expressive logics. A little bit of higher order logic. Ubiquitous in human conversation to be able to say things like, Mary believes that John likes Sue. So here we've got a predicate, a relationship between an instance and a whole formula, a whole statement that has a truth value. We say things like this all the time. Mary believes that Joe knows that Mary's car got broken into last night. These can be nested arbitrarily. This is even more expressive logic. It's harder to reason with, but it's very useful, and it's part of representing our world. We've got to be able to say things like this. So, all that said, I would contend that implementation is different from representation. So early on, we made a kind of a design decision with SUMO that even if the technology didn't allow us to do fast and efficient inference right away, we were not going to hobble our description of reality with the limitations of logical inference at that time. And that just turned out to be a very good decision, because since the 10-year start date of SUMO, in the past year and a half, I've had a colleague that's an expert in higher order logic actually implement or integrate his higher order logic reasoning engine with our system and be able to do reasoning in higher order logic with SUMO. So if we'd made this restriction, we would have lost that whole ability. But instead, we capture this information. We know we can't always use it. We know it's difficult, but we've gone forward and describing our world as it exists and not forcing the description of the world into this sort of very restricted little space dependent upon the technology that happened to exist on the day we started. A little digression here, open source. Open source is a good and wonderful thing. Become a believer in open source. I wish I were Richard Stallman and I could expound for hours on open source, but I'd just say it's been a key enabler not only for SUMO, but also for the WordNet project that I'll talk about in a little bit. It's opened up possibilities of having volunteers from around the world. It's meant that SUMO could be adopted by students in third world countries. It's meant that people have been able to do things with SUMO that I never even would have anticipated, simply because they picked it up and they were creative and they did something for it because it was free. They had the opportunity to do something very speculative. In fact, one of the interesting early applications of SUMO was done by a group in Taiwan that they translated all of the SUMO labels into Chinese. They actually do all of their browsing of the SUMO theories in Chinese characters, not in the English characters that it's originally defined in. And they used it to test theories about linguistic analogy. So there's been a lot of research about analogy in language, and I think it's suffered from not having a lot of objective tests to prove whether analogies that are sort of proposed experimentally are really valid. Well, with SUMO, they were actually able to do this because they could say, okay, here's an example sentence, we'll formalize that sentence, and we'll see if the facts that hold true for the true case, if you will, the original case, hold also for the analogically valid case. Right? So they can actually just test the facts and quantify and say, oh, the analogy really does hold because the facts are still true in both cases.
Open source has problems in licensing. If you're doing the Free Software Foundation license, you can't use it in something that involves a trade secret. You may contaminate your trade secret, wouldn't you?
Well, actually, no, not in all cases. There are, with whatever license you choose, if you choose a proprietary license or you choose one of the variations of open source licenses, there are use cases that are not going to be open to you, right? So every license doesn't work for every person, every company, every situation. For Reardon Commerce, open source GPL is what I licensed SUMO under. It's worked perfectly well for them because they do everything software as a service. So they never actually distribute their software. So it contaminates their software, but unless they distribute the software, they don't have to distribute the source. They don't distribute the software. So that's why we have the Afro GPL license, which is not what I use. Afro would prohibit that as well.
As long as they use it in-house, they don't. But they're selling a service to customers, and the customers can come back and say, why did you choose that hotel for me? Show me why you did that. And then when they have to open up all their sources that they have, all their proprietary information, particularly in the middle of a lawsuit, then everything would become disclosure, and their entire software base would be open.
Well, I'm sorry, I just realized I haven't been repeating all the questions. Yes, so there's a thumbs up. So lots of questions so far that are not going to be part of the audio. So let me take a moment to just paraphrase briefly without destroying your question. So another question about, yeah, so if there's some legal case, doesn't that have a problem with open source? Doesn't that become a part of disclosure? Well, that same disclosure, I'm not a lawyer, all right, so I can speculate a little bit, but not my area really. But as far as I understand, disclosure works when you have completely proprietary software too, and that's the subject of more sorts of litigation, right? What during disclosure does all your proprietary source code get disclosed? Well, it's supposed to be disclosed to the other side. I don't know. We should talk to a lawyer. I don't have all the answers in that regard. Talk to Richard Stallman. I just know that open source has a lot of advantages. Works in our case. It's worked in all the cases that I've seen for a long time. There are cases that wouldn't work. Plenty of people wanted to use it and put it in a proprietary product, and I didn't allow that. Okay, I closed off that portion of adoption.
The major source of money, but I struggled for 10 years trying to track down sources.
Yeah, so a follow-up question of, the fact that I've made it open source means I didn't make any money. Well, yeah, I thought 10 years ago that no one was going to buy my ontology anyway, and I think I'm probably right. I'm not even sure right now that many people would be buying my ontology. At least people are adopting it, and that's really what I want. Great, so I'm a failure as a venture capitalist and businessman, but hopefully I'm a success as a scientist. That's good enough for me. Upper ontology. Moving on, sorry. So there's been lots of work in ontology, and lots of people argue about upper ontology, whether it's a good thing. I think it is. I'll try to justify why. The point of upper ontology is to try to gather all the things that we know that are true in lots of domains, creating some superstructure for our information that's true in lots of places. I think it has some additional benefits. Certainly large-scale reuse is one. You do a project in one domain, and you go to another domain, and if you've linked to SUMO, then all your stuff is guaranteed to be compatible, right? If you just do everything in silos, you're almost guaranteed to be incompatible in the terms that overlap from domain to domain. And inevitably there are. I'll talk a little bit about what my case about how much ontology does overlap between projects. Another thing in terms of promoting good reuse and good code development is that an ontology that's already created acts as a reminder about things that you need to make decisions about. Right? If you start with a blank page and create your ontology, there's no way you're going to remember or know about all of the different factors that go into how should I define this term. If you have a large ontology that forces you, at least at the beginning, to say, all right, I've got 1,000 leaf nodes out here in my structure. Is it this or is it that? Is it C or is it D? Is it this or is it that? You've got all these choices to make immediately about where to put your term in the hierarchy. These are reminders about factors that you should consider in your definition. And having made that decision, then you inherit all of this wealth of information. Another thing that always amazes me is that reuse is absolutely a necessity and part of the best practice in any modern software development. We don't go out and say, all right, I'm going to write a hotel booking system, and so I guess I better start writing my own operating system and my device drivers and a database system so I can access my database. And of course, nobody does that. We reuse this massive stack on any practical project, unless we're doing something very obscure. And I gave a talk at Google once, and they said, well, we write our own operating system. Well, okay. But still, you guys, I'm sure if anybody's here from Google, there's still lots of code that you reuse, even if it's the code that somebody else wrote at Google. You're going to be reusing. You're going to be reusing some specialized operating system work. So this is absolutely standard in modern software development, but for some reason, there are people that resist this best practice when it comes to information design. Why shouldn't we be reusing information definitions? Now, there are reasons why people are afraid of that, but I contend it's simply because they haven't actually studied something like SUMO that would allow them to follow this very standard best practice in the software development community. So why use upper ontology? Here's just a little hypothetical, kind of fanciful example. Imagine your 1-800-Flowers and Harley-Davidson motorcycles, two vastly different businesses. How could they possibly have anything in common? Well, of course they do. You know, they both need to share information with a shipper like FedEx. So they're both going to have information about weights and dates and measures and money and taxes and all of this stuff in common. Now, you can just map everything and do this kind of pairwise integration, and that's kind of the standard in the world today in terms of software integration. Every time you have a new partner or a new information source, you map that stuff into your product, and you get a new partner, and then you map your whole database into their product to connect them all. Very time-consuming, very manual, very labor-intensive. And what you wind up with this pairwise integration when what I think we should really be doing is a hub and spokes relationship where SUMO is the hub, defines all these things, and you keep adding content to it. And of course, that's what I've been doing over the past 10 years. It's much more efficient. You wind up accreting a single product instead of doing these sort of bottom-up pairwise integrations. It works faster, and I contend that it gets you better quality. So a lot of people claim upper ontology is impossible. I get that a lot. It's fundamentally an unscientific claim, because somebody can always say, well, you've got a fatal flaw that's bound to crop up on your next project. And then I saw do that next project and say, well, that doesn't prove anything. You're bound to have a problem on your next project, right? So it's not falsifiable. So it's not a scientific hypothesis. It may be a reasonable hypothesis, or it may have been a reasonable hypothesis 8 years ago or so, before we had so many examples of actual success. But I think fundamentally there's a failure of intuition with folks that believe upper ontology is not possible. And I think it's a failure to discriminate amongst these three things. To me, there's ontology that is an expandable, language-independent, machine-understandable product. There's language, which is something that's evolved organically over time. It's understood by humans. It's necessarily very ambiguous, very informal. And then there's knowledge out in the real world that may change rapidly. It may be very local to people or cultures or entities or organizations. It's not going to be shared by everybody. And so as an example, let me take another fanciful example. So let's talk about two groups of people. One believes that unicorns exist, and another believes unicorns do not exist. Those two groups of people can still communicate with each other, right? They can still define in their ontology the notion of a unicorn as this horse-like thing that has 4 legs and a tail, and it's about this large, and it has a horn, without ever committing to whether there exists at least one or there doesn't exist one. That can be knowledge that can be kept local to our two groups while they still share the definition and therefore communicate about it. So maybe not everything can be shared amongst every group of people, but at the very least we can share what we do actually hold in common, and that's considerable, because if there wasn't a tremendous amount of information about knowledge about the world that we held in common, we wouldn't be able to communicate at all. Right? And so people focus on this stuff at the fringes of knowledge, at the fringes where there's disagreement. That's not the center. Let's at the very least define all the things that we do hold in common, because that's useful. SUMO and WordNet. Let's talk a little bit about this. So down to some specifics. So SUMO started out as just an upper ontology. I keep thinking I should rename it as, suggested universal merged ontology or something of that sort, because it's no longer just an upper ontology. We started out at about 1,000 terms, 4,000 statements, specifically 750 rules. We did a big project early on to map to all of WordNet, this lexical database, a collection of word meanings, kind of like a dictionary. This was a really big project. So WordNet has 100,000 word senses. It's about the same size as a standard collegiate English dictionary. We went through the entire set of sensets one at a time by hand over the course of an entire year, mapping WordNet senses to SUMO terms. A really big job. My colleague Ian Niles did about 91,000 of them. I did 9,000 of them, so I could feel some of the pain that he had. Turned out to be one of the best projects we ever did in terms of getting SUMO adopted by different people for different reasons. It linked language to formal logic, to ontology, and it's been really valuable in all the years since. And we didn't just stop there, we did a lot more. I'll come back to this in a moment. Yeah?
Did that evolve the ontology?
Absolutely. Yes, the question is, did that project evolve the ontology? And absolutely it did. So it acted as an excellent check on the coverage of the ontology, especially early on. When we started doing the mapping, we found linguistic elements that described our world that we hadn't considered. And so we said, hey, well, if we're going to link in this word meaning, there's just no obvious home for it. Do we link it at the top to entity? Well, that's obviously not right. We need more. We need this whole branch of the tree defined, and so we did so, and we greatly expanded our coverage as a result. Now, SUMO doesn't cover all of WordNet down to all the bottom leaf level terms in this 1,000 word sense dictionary. We keep getting it more and more specific every year, but we don't have equivalents for every term. I mean, there's some very specific, even phrases, not just individual lexicalized items, individual words in WordNet. So it may be a while before we cover absolutely everything, but we're getting there little by little. Yes?
This is an off-the-wall question, but are you sort of over time proving that the Worfian idea is not?
That's great. So the question is, what about the Worf hypothesis that language influences thought? And so when I want to tweak somebody in the audience who's a Worfian, I say, yes, that's, SUMO disproves the Worf hypothesis. I'm not sure that's really true, but it certainly should give any Worfian pause in that, I'm sort of previewing some later slides, but there's been a lot of work that we've done in expressing SUMO, the surface form of SUMO in other languages. So I mentioned the folks in Taiwan that were browsing SUMO entirely with Chinese term names that translated the English term names. And we've got SUMO projections, ways to express SUMO terms in many other languages: Hindi, Italian, German, French, Bulgarian, Romanian, a couple others. A wide variety, different language types, different language families entirely. And no one's ever come back to me and said, this is fundamentally incompatible. I just do not know how to say this in my own language. That isn't it isn't a firm proof that Worf was wrong, and I'm sure his thesis is a bit broader than that too. I'm kind of narrowing it down to a very specific assertion that language is just so specific that there's no way to have a common upper ontology for all different languages. Is kind of what one of the things he was getting at, I think. But I think there's some indication, at least, that SUMO is, as defined currently, not deeply culturally or linguistically dependent. Right? It seems to work well elsewhere. Okay, I think I've talked about some of the other things on that slide, so I'll go on. So as I mentioned also, SUMO is formally defined. It's not dependent upon a particular implementation. We've got a big open source tool set for doing useful things with it that I'll try to talk about if I have time. Lots of people are using SUMO, lots of people are publishing about SUMO, and then I'd like to think that there's a whole sort of dark web out there of people using SUMO that are not academics and aren't publishing, right? And I get queries on occasion from people that will say, I have a question about SUMO and I'm using it in this sort of vague particular way, and I don't really want to tell you anymore, but can you help me solve this problem, right? And so I don't really know what they're doing, but I know they're using it and they're asking good questions, so there must be some reason they're using it. So I hope that there are as many commercial users as there are academic users. And of course, there are some that are willing to be forthcoming, and I've done a lot of consulting for companies trying to do at least minor applications with SUMO over the years. So SUMO has a structure. It is not a monolithic ontology, as some people claim. In fact, even the upper level, it can be decomposed into this 11-part structure. Obviously, there are some dependencies. Some parts depend on others. But if you don't need anything in your ontology that sort of is graph-like, like road networks or computer networks, you don't need to use that part of SUMO. It's not relevant for you. Don't use it. SUMO's gotten very big. It's not just an upper ontology. We have done tons of applications. All of my early applications for the previous 10 years have been kind of government and military focused, because that's where all the research money was. Now that I work for a commercial company, just since April, we've released ontologies of hotels and dining and food and lots of other things related to travel, and we keep releasing new stuff every day, or every week at least is our general release schedule. So there's tons of new stuff out there. It's growing massively. I just keep hoping more and more people use it.
There's stuff done by Pease, and you have your own upper ontology. He kind of breaks the world down into 3 by 2 time and then 2 more 12 all in all, and they don't map onto what you have.
Actually, they do. Firstness, secondness, and thirdness, I would contend. Yeah, repeat the question, thank you. So the question is, with regard to the philosophy of Charles Sanders Peirce, how does SUMO express his canonical notions of firstness, secondness, and thirdness? And I would say that
Current, physical, abstract, those are the 3 flavors of statements.
yeah, let's see, continuous, continuant, occurrent.
Whether something exists
Yes,
throughout time.
those are easier. Those are easier in SUMO. I'll talk about that in detail in just a moment. Well, so the upper ontology, well, okay, so maybe I've confused you by this slide. So this slide here talks about sections of the ontology. These are not terms in the ontology. These are not concepts. These are informal descriptions of the 11 groups of axioms that exist in the upper ontology, right? So we do not have structural ontology as the ontology root. No, there is an ontology that we call the structural ontology that has many things that are named in it that are at the top of the hierarchy. Are we allowed to use informal terms? Well, yes, as long as you define them formally. Right? So back to Charles Sanders Peirce. So I would say that he created these notions and he named them in particular ways, and we have them just by different names. So I would say that firstness is sort of broadly the thing. Let's see. He called it the thing in of itself. That would be the class, a class definition. Property. Then we have secondness. Secondness I took more to be properties. Relations is secondness. Okay. So of course we have relations in SUMO, and we have thirdness. We have statements that are relations between two things. I don't think his stuff is all that magical. Right? It's perfectly sensible, but what it turns out to be in the ontology is stuff that every ontology has. I don't think you need a precise concept. Certainly not by that name of firstness, secondness, and thirdness. Now, continuant and occurrent, we have object and process. I'll talk about those in a moment. Those things that are farther down are much easier. So, this is a problem that a lot of analytic philosophy suffers from, and why I wish that philosophers would actually define their terms not in English, but in mathematics. Because if they did, we could actually test how well it works, as opposed to reading something that's sort of entertainment for the mind. So sorry philosophers. It's a little biased, isn't it? Okay, SUMO validation. So I already mentioned mapping to the WordNet lexicon, great check on coverage and completeness of SUMO, peer review. SUMO's been open source from its inception. It can be kind of painful putting stuff out there, especially when it's brand new and half-formed. People say bad things. They say your stuff is all wrong. But a lot of times you get very constructive feedback that they may say why it's wrong, and then you go back and you fix it and you make it better so that they can't say that the next week. So there was a lot of this painful stuff right from the start. It wasn't fun always, but it was very useful. Formal validation with a theorem prover. So because we actually have a formal language in a formal logic, and we have automated theorem proving that can operate on that formal logic, we can try to prove contradictions, prove logical contradictions. This has also been a very fruitful line of research. We were able to show, very early on, using the vampire theorem prover, that we had a number of contradictions. And vampire continues to improve so dramatically that just recently, we've actually had reports of 100-step proofs that show us a contradiction in the ontology. We go in and we fix it, eliminate the contradiction. This is a kind of formal validation that simply isn't possible if you use a language that isn't amenable to automated inference, isn't completely specified as a formal logic. And application has been a key. Every time we do some application, we find stuff that could be better or needs more detail. Natural process. WordNet, a wonderful thing. As my inspiration for an open source project. It's been around between 15 and 20 years. It's been used for all sorts of different things that many people had never anticipated. It's become almost a de facto standard in the linguistics community. In fact, there are many people that will use it and sort of keep secret that they use it because it's just so useful. They can't do without it, but they don't want to, let everybody know that their commercial product actually uses WordNet. WordNet has a very free license, so people are free to use it and then resell it, which is interesting. But a great project. And thanks to Christiana Fellbaum and George Miller for doing this work. It's just tremendously useful. But WordNet is not an ontology. And if you actually ask Christiana and you ask her the right questions, she will tell you that it is not an ontology and not intended to be in a formal ontology, even though occasionally it is, people attempt to use it as such. If they do, and they do formal inference, and they try to follow any of the links in WordNet, especially as you get up towards the top of the hierarchy, or you follow links, transitively, say 10 deep, you'll find you get some pretty odd answers. You get some things that aren't consistent, they aren't true. Because that's how language is. It's informal. It's not meant to be consistent. It wasn't created consistent as it evolved over time. Very different than a formal ontology. There's also many things that are simply not in WordNet. So for example, this little very trivial axiom that's in SUMO that says if I have two intervals, one is earlier than another, then that means that the end of the first interval is before the beginning of the second interval. Now, WordNet has a word earlier, but it doesn't have this axiom that allows you to make that deduction if I have two intervals. And yet a person can do it. We need to record this information. It's not terribly exciting by itself, but it's absolutely necessary. It's part of the description of how the world works.
I'll ask the probability question now, because this seems to be missing a probabilistic description, because it's earlier isn't necessarily separate, but it could be overlapped or whatever by various measures of certainty or something. We'll talk about that.
Okay, so the question is about probability. Where's the probability in SUMO? Well, so first off, your notion about, earlier may be really earlier or may be connected or not, the start may be earlier. Keep in mind, these are not words that you're seeing here on this slide. These are formal terms that have a formal definition. Now, you may have an intuition about what earlier means in English. That is not necessarily what it means in SUMO. Right here, think of what we're doing here as though you're programming, right? You're writing a variable name or a method name in some Java code, okay? And so you hope that you've done some good naming and that the intuition that you provide to the reader of your code is consistent with its formal behavior, but the definition of a variable or a method in Java is not what your intuition tells you. It's what the code actually says it is. It's what the code actually does. And the same is true here. It's our formal definition in logic of earlier that governs what earlier actually means in SUMO. And we hope we name it correctly so it's consistent with your intuition, but you got to read the code, just like you would if you were reading Java code, right? Now, in terms of actual so to answer part of your question, earlier really means definitely definitely earlier, logically true. Right? Black and white. It's a two-valued logic, true and false. That's what we have here. That said, we do have some facility for talking about one fact being more likely than another, or one fact having a posterior probability of such and such. We can say these things in SUMO. It's not primarily what it's designed for. I mean, if you really want is a probabilistic logic, use a probabilistic logic. And there are going to be some certain classes of things that are true about the world that are maybe best not modeled in SUMO. We don't claim to cover absolutely everything or be the best tool for every job, simply a good tool for many jobs.
Follow up, if you're doing natural language translation or trying to represent natural language, then that's where the rubber meets the road, where the probability would seem to be very important.
So the question's about natural language processing. Don't we need probability for that? And I think we do, or at the very least, we need the sort of partial order that statements in SUMO can be given. So we could say that this interpretation is more likely than that interpretation. We don't have to give everything a number. There's more than one way to do probability. that's consistent. I'm a particular fan of the thesis work of Paul Cohen, even though he doesn't like his work now for some reason. I thought it was really cool, where he came up with a qualitative way to reason about probability. And basically, it's based on sort of partial orders. This is more likely than that, as opposed to saying this is 0.8 likely and this is 0.7 likely, which I think sort of summarizes and loses information and creates a total order where none necessarily exists. So we could have a longer discussion about probability and sort of my soapbox discussion of why probability, I think, has been misused in a lot of cases where people are attracted to it.
Similar vein, you might expect that an orange is usually orange.
Yeah.
But, a young orange, an immature orange might be green. Can you capture that kind of distinction?
Well, so it's certainly, yeah. We certainly capture distinctions like that. I mean, we have the notion of immature animals and organisms, and we can talk about their qualities or their attributes at different points in their existence. The things that we would have trouble talking about are sort of this fuzzy transition between childhood and adulthood, or an unripe orange and a ripe orange, where it's a little bit green, it's a little bit orange. Maybe you should look to fuzzy logic for something like that. This may not be the most appropriate tool for that.
So do you try to capture the notion that an orange is orange in color, for example?
I'd have to check. We've got 80,000 axioms in SUMO, and I don't have them all memorized. I'd like to think that's in there somewhere.
When you talk about young animals, old animals, that concept, mature animals, young animals, are you capturing, if you talk about an animal and make it the default presumption that the animal is mature, or you try to back off from that and say this is an animal whose state, maturity we don't know?
So follow-up questions about talking about the maturity of organisms. What facilities do we have for that? So there are lots of things that we don't say when we don't know, right? As human beings do that all the time. SUMO does that as well. So you can say that there exists an animal without being specific about its state of development. Yes, another question. Excuse me. Yeah, so the question is sort of a general question, but a specific example about dogs. And yeah, the dog that only has 3 legs, is that still a dog? Well, I would say yes. And if we would have to go in and look at dog to see whether it accorded with your intuition about the boundaries of that class. In some cases, you're going to have fuzzy boundaries. And so we simply try to talk about what is true. What do we know that is true? And there are going to be things that are left unsaid about certain boundary conditions, simply because maybe we haven't gotten to it, or maybe it's simply hard to pin down. There are lots of things in the world that are very fuzzy, and we don't attempt to pin down those things that are so fuzzy that we can't create a precise definition for them. We try to define what we can define precisely and no more.
But you could precisely say that many dogs have 4 legs.
Absolutely. The question is, could we say that many dogs have 4 legs? Yes. Is it very likely that dogs have 4 legs? We have a whole collection of partonomic predicates about initial and typical parts. So we can say that it is necessary. Every thumb starts its life as part of a human hand. There's no disembodied thumb that comes into being in this world. We can also say that it's typical that every hand has a thumb. Not necessary, but it's typical. Right? Very different state. And then we can also say specifically, this hand does have a thumb right now. 3 very different things. I've yet to see an ontology that actually has those relationships. Very important very important aspects of describing our real world.
Does that mean you can be self-descriptive about the ontology?
Question about does this mean we can be self-descriptive about the ontology? I haven't found a utility for that, I guess. Reflexive description, it's something that you hear about in certain kinds of Lisp programming. Sounds cool, but I haven't found a need for it yet. Okay, onward. Internationalization. I talked about all these languages that SUMO is connected with. All this is volunteer effort, a benefit of open source. Just students did these things. In fact, the first student to do this, the first year that I released SUMO, I had a message out of the blue from a student in the Czech Republic. He said, "Oh, I'm really interested in your ontology that you released." And I answered a few questions, and 2 days later, I think it was, he wrote back and said, "I have created a browser for your ontology, and oh, by the way, I've translated all your term names to Czech." And then a week later, we had some more discussion about presentation, paraphrasing of statements in logic in other languages. And he said, "Well, I've written a language generation system for your ontology." It's like, this guy was amazing. And that's the sort of thing that you can have happen when you give things away. So this is something I alluded to earlier. Are SUMO terms directly usable? You get people that will say, "Well, no, I don't want an upper ontology. I'm just going to create the terms that I actually need for my application. I'm not going to worry about this general level. It's simply not necessary." And so actually, even before we created SUMO, we did a study as part of a large DARPA project where I think we proved something that shouldn't have really been surprising. In any sort of practical project that you have, if you're talking about things in the real world, you're really describing the world, how can you possibly get away without having a relationship that says something happened before something else? Or that a particular individual was the agent or the motive force behind a particular process, an event in our real world. These are obvious things that a practical project, any large practical project, is going to need. So we did a particular project here where we were actually answering a lot of questions about international trade and terrorism and other things the military cares about. And so we were able to answer these test problems. Because we're using formal logic, we had proofs, so complete formal descriptions of how the answer was derived. And then that gave us a possibility to just do some simple analysis and say, for all of these proofs, were there terms that appeared with a given frequency? And so we found that 1/3 of the terms that were used in the proofs were clearly from the upper ontology. They were things like, agent or patient or earlier. Not surprising, but we could quantify it. Why one upper ontology? Many reasons. Translation is hard. You have two people that create two different ontologies, and you're almost guaranteed that they're going to carve up the world differently because there isn't one true ontology that everybody just converges on. People have different ways of looking at things. I would contend that because there have been several, I think, comprehensive and successful formal upper ontologies, that also should be a kind of existence proof that one of them isn't sort of the one true way. Right? There have been a number of groups that have tried to do this with a degree of comprehensiveness and success. There's more than one way to carve up metaphysics. But pick one, because if you try to map them to one another, it's really hard. And I'll give you an example of why that's hard. So there's many possible upper ontologies, but there's really a lot of bad ones. Pick a good one. Ontology and language are different, so just kind of continue to hammer on this point. So here's a question actually I got from a SUMO user or prospective user. He said, "I don't like your definition of landing. I think it's wrong. It clearly doesn't allow for planes." And so I said, "Well, okay, that's your intuition about what landing means in English, but we're not talking about English here. We're talking about a formal logic, a formal theory. That's the name we gave to it, but the axiom that we have for landing landing a boat was what he was talking about. What we did here was define landing as landing a plane that comes through an atmospheric region. Right? So we made that decision. We created this term, we defined it. That's what it means. We have another term about landing a boat or docking a boat, just named it differently. Right? We're not talking about English with these names. These are formal symbols in a theory.
When you have landing a boat and landing a plane, there's something very similar about them. Landing a plane was probably taken from landing a boat. Is there any attempt to find out the similarities to capture, there's a specific generic relationship here that could be going on?
Well, absolutely, because we reuse all these terms in the definitions, right? So that we have the notion of that it holds during, that it's located in a particular place. We have things like origin and destination that's specified. It's not in this particular axiom, but you'll find that something like destination says that, if you have a landing, whether it's landing a plane in this case or docking a boat, you'll find that the axioms will talk about the destination of that particular thing. They'll talk about that this involves a vehicle, right? So that's part of the structure of the ontology. Now, we don't have to have a particular named relation that is defined between landing a boat and landing a plane for there to be commonality and a relationship that is inherent in the axioms that we use to define these things.
Aren't you missing the reuse?
Not at all, because all of these terms, are we missing the reuse? No, because look at all of these terms that are all reused in all of these different axioms. There's tons of reuse. That's why this is valuable.
Well, it seems that you have the land-water case and the land-air case.
Yes.
And there's something common about the two, and then that you could, if you had a smaller axiom, I know it looks pretty small, but even a smaller set of things that you would gain from that you would be able to make better inferences.
Well, a smaller axiom. If our axiom was, this is as small as it can be and represent the fact that we need.
You had a destination coming in for a destination and arriving at your destination.
Right.
And you can land a train coming into a station. And
Might say
there are
that.
certain things that happen in each of those cases. So there's some commonality that you expect out of all those situations.
Right.
So couldn't you have a generic axiom that covers all of these cases?
Well, in fact, and we do have axioms about vehicles that do specify what's in common amongst vehicles. So yes, we absolutely capture this commonality where it exists. And we could look through the ontology, if you'd like, probably offline, and try to help you understand how this reuse has actually been achieved in practice. All these terms are reused in many, many different axioms.
What are the implications of changing something like this upstream and downstream? Because we're debating whether this one is right.
Okay, so the question is how do we handle change management in SUMO? And we handle change management through actually conventional source code control. We use CVS. So it's not CVS is not a substitute for management, they like to say. So there's no magic here. The ontology does evolve. Things do change. And if you have an application that depends on an earlier version, just like software versioning, there are going to be issues in upgrading to the latest. So.
If you were to, as was suggested, if you were to refactor this so that it could be more broadly, a narrower, a smaller version of this could be more broadly applicable, and then you could still define landing in terms of that other one. If you were to do that, you could prove that the two definitions of landing, this one and the one in terms of a refactored one, were the same.
Well, yeah, so that's an interesting notion that makes very precise, if you believe there is a better way to express this that captures more information, that doesn't lose any information, that at least is an objectively quantifiable thing, because we can do proofs, we can ask questions to see whether the same questions are answerable in the new version that are answerable in the old version. So it takes away, when you have this level of formality, it takes away a lot of subjectivity. That's what I wish a lot of people in the ontology world would sort of work on and pay attention to, rather than what are often more aesthetic arguments about what's better. You don't have to talk about what's better in sort of generic English, paragraph kind of terms. You can say, my ontology is better because look at this test. I ask this question, I get an answer, and your ontology doesn't get an answer. And this is something that your ontology should be able to define. Give us hard test problems. Show me how, whatever you're coming up with, or, Joe, alternative ontology developer, show how your ontology can come to a different and better conclusion. Then it's objective.
Right, and I would think that even without specific tests, that you could draw some inferences about this definition versus that definition.
Well,
You
yeah,
compare them more directly.
Well, yes. So take one definition out, substitute in a new one, and you can show what's different. You can prove what's different. So let's see. So we're kind of running up to about 8:30, and I don't know, we've had a lot of questions, so maybe if people are agreeable, I'll just keep going, but know that you're welcome to keep asking as many questions as you have been, because I'm about halfway through my presentation. So, so Sigma, let me talk about the tools. All right, so maybe this should go faster. There's nothing controversial here at all. Right? So Sigma is an IDE for SUMO, so analogous to Eclipse for software development. You need this stuff, right? And also, some first contentious thing in the news section, which is not intended to be contentious, I would say that a lot of people, when they use SUMO, download SUMO, they say, "Where's your editor?" And I say, "It's an IDE. Your editor is your text editor. It's like writing Java code. Sure, you have a tool set that gives you your class hierarchy and has nifty other features, but it's programming. You write in a text editor. There's no magical graphical tool that's going to help you or that's going to take over the trouble of creating an ontology for you." Now, I can see why people have that intuition. If your ontology language is OWL and most everything that you do is just a taxonomy with some slots, then sure, graphical editor is going to make a lot of sense. If your language is that restricted, there's not much you can do. Very easy to come up with a visual metaphor for it. But if you actually want to be able to say everything you can say about the real world, you need more than that. And that's why I liken formal ontology development in SUMO to be more like programming. There's no magical programming tool that lets you draw pretty pictures and write the next database system. So Sigma functions can be broken down into things like mapping, merging, and translation, browsing and display, analysis and debugging, and inference. For mapping, merging, and translation, we have a simple string distance-based merging tool that will do string comparison. I did some work in mapping and merging ontologies, and there are lots of algorithms, and there are conferences about all this stuff. I found that for me, in practice, if you have a really big ontology like SUMO, and you have other stuff that you want to merge in, usually the other stuff doesn't have a lot to grab onto in terms of its meaning. Most of the time it's going to be just a taxonomy with some term names. Maybe if you're lucky, some English definitions, a few frame slot kind of things. Most of the value I found was in just having a really nifty GUI that kind of lines things up side by side based on string match. You say, oh yeah, that matches and that doesn't match it, and that matches and that one doesn't match. That was most of the value, and I tried different, even matching algorithms. Most of the value was, the machine has so little to go on, most of the time it guesses wrong no matter what you do. That's my bold assertion why ontology merging and mapping is actually, I think, a lot of misplaced effort. First, you need to actually have something to grab onto. Do the work in defining these ontologies formally. Then we'll have a way to actually compare to see whether they mean the same thing. I have a lot of supported languages. SUMO is natively written in SUOKIF. We do have an automatic translator out to OWL, so if you don't believe me and you still love OWL, you can do all SUMO-based development in OWL. You lose most of the axioms, because most of it's not expressive in the simpler logic, simpler description logic. But you get the hierarchy, and that's better than starting from scratch, I would say. We do Prolog. We have the TPTP language that's invented by Jeff Sutcliffe and his colleagues. That's first-order logic and is used in the International Theorem Proving Competition every year. And there's also this new work on THF, typed higher-order forms for higher-order logic, thanks to primarily Christoph Benzmueller for doing this work and integrating SUMO with his Leo 2 higher-order prover. Very exciting work. Browsing and display. You spend most of your time doing development in SUMO in terms of the Sigma tool set, looking at stuff like this, where we have walking is our term, and we have some nifty images. And let me talk about the images, because the images are really cool. So this is a great use of Mechanical Turk. So I put a request out there. I'll pay you $0.25 a link if you link Wikipedia images that are common, open source, Creative Commons, to terms in SUMO. And so it wound up being that there's a Russian guy. I kind of imagine him at his mother's apartment in Moscow typing away for $0.25 a link. And the guy was phenomenally productive. Every day I'd get several hundred new links. Some weren't great because he did a little bit too much matching based on just a term name and not really deep definition. But most of it's pretty darn good. And he actually, I'd pay him $0.25 a link, and he said, oh, by the way, I came up with these other 10 links for this term as well. So he volunteered all this extra information, which was just so cool. So we have like 11,000 image links now. So, any sort of common sense term that you browse in SUMO, you'll come up with things, like this nifty little animated GIF of somebody actually walking. It's very cool. Fun stuff. We have all the links to WordNet, word census. You can click on this and look at the word and look at what WordNet says about that word. We get all the formal definitions nicely hyperlinked. We get these natural language paraphrase, and so we're paraphrasing English language right now, but we can do paraphrases in Hindi and Tagalog and various Chinese, etc. Fun stuff. Analysis and debugging. There's lots of things we can do because we have this formal theory, so we can actually check it. We can prove whether it's consistent in a sort of restricted sense, which I can talk about maybe not now, but at some other time in detail. So we attempt to prove inconsistency. It's incomplete, but we do find problems and we correct them, and that's a good thing. There are other special case tests that we can do just in the Java code and without resorting to the gigantic hammer that is automated theorem proving. Things like rootless terms or no documentation. Some are just warnings, some are other errors, but it helps to improve the ontology when you catch these things. We have various degrees of integration with a lot of different theorem provers. There's an old version of Vampire that was specifically open sourced and adapted for SUMO. Some of the coolest new work, and I talked about Leo, didn't talk about Sign. So so the Czech Republic seems to be a great place for really brilliant computer scientists. So I've run now for 4 years a division of the International Theorem Proving Competition for large knowledge bases. Their competition used to be primarily for proving really tough theorems about small numbers of axioms. So they'd have, say, 6 axioms that axiomatized a portion of group theory. And there'd be a query, and they'd have to prove that some answer was true in this little theory about group theory, portion of mathematics. And they weren't working on the problem that I care about, which is you have tons of things that are true about the world. I ask you any given question, and most of your knowledge is completely irrelevant. But you have to find that few set of things that are relevant, that are true, and that are needed to answer the query. So we started giving these folks all of SUMO. All of SUMO is mostly a distraction for any question we could answer, but it's a realistic case for decision support or question answering on a large knowledge base. And that changed the character of the problems that these automated theorem provers were trying to solve. And so the first time we ran it, before we ran the competition, we did kind of a baseline test. And then we ran the competition. There was this guy in the Czech Republic that came up with the SUMO inference engine. And he did a technique called axiom selection. It was kind of an information theoretic measure where he goes out and sort of makes a best guess at the set of axioms that should be relevant to your query based on the sort of graph theoretic connectivity of terms. Tries to get the answer. He sends this subset to the theorem prover, has a more restricted set to worry about for its search space, hopefully gets an answer and gets an answer a lot faster. He's just revolutionized this whole area. When we started the competition, we had problems that I would call easy problems. They used just SUMO, the upper level, and we allotted, I think, 600 seconds per query, and half of the problems couldn't be answered, and those that were usually took at least 300 seconds. Well, this year, we're now asking questions on all of SUMO, including all the domain ontologies. So an order of magnitude, 2 orders of magnitude bigger theory, almost. And now the best prover, Vampire, which now includes Sign, because of course somebody hired this bright young guy, and it was the guy that was already doing the best theorem prover. He rewrote the whole system. Now we're getting answers to the hard problems in 3 seconds. Several order of magnitude improvement, just brilliant work. Very exciting. And there are lots of other engines too. People are doing all sorts of cool stuff that I don't have time to talk about. Don't have time really to talk about this. There's lots of sort of pre-processing that we do to get SUMO into the right form that these engines can handle. Some of this is in my book that you can read about. Inference. This is kind of what you see when you do an inference in Sigma. So we've selected Vampire as the prover, but you can select any number of different provers, and you get a binding. So you ask a question with a free variable, you get back a binding and answer, and you get back a sort of textbook style linear proof where each step is explained. just like you'd expect from high school geometry, where you have a proof and you have to justify each step, and each set of steps leads to a later stuff until you get to your answer. Pitfalls in ontology development. Maybe I can breeze through some of this because I think this is my attempt to summarize some lessons learned in ontology development. Instance versus subclass. The most basic kind of distinction you'd ever expect to have in any kind of ontology, an individual versus a class, and yet one of the most popular in terms of its Google ranking, introductions to ontology by some people that are very well known and as sort of serious ontologists and educators about ontology, actually gets this totally wrong and has a class that's called an instance. I mean, it's amazing. Very prevalent problem. So, Bob, the individual, is clearly an instance of mammal. Human is a subclass of mammal. There are these boundary cases that are much harder. I've run across this one where Streptococcus is still a class unless you have one instance of Streptococcus, that particular bacterium. I've seen this problem come up a lot in terms of actions too, where this talk is a particular instance of talking. Right? It's not a class, it's an instance. Corollary with this, if you have only one type of link, you'll wind up mixing them. So if you just have a taxonomy language that says more specific, more general, you can't make this distinction. It's not in your language. Got to have an expressive language that allows you to make these distinctions. This one is almost ubiquitous, especially since the semantic web, you get instance and subclass in the standard OWL language. You don't get a part of relation. You have to define that yourself. Well, the fact is most people don't define it. They overload and misuse the subclass relationship as though it was part of. See this all the time. Now, you could say, oh, well, sure, but I know what I mean. Well, unfortunately, if you actually do inference, even with Sparkle, you're going to get wrong answers if you fail to make this distinction correctly. Right? So a wheel is a part of a car, not a more specific type of car. With processes, this also crops up. So an opening argument by a trial lawyer is part of a criminal legal proceeding. It's not in and of itself an entire criminal legal proceeding. Happens all the time because part of isn't there. Another simple reason that we should be reusing stuff, not just creating our own, because sometimes people get it wrong. Modeling events as relations. This you don't see so much, but I like Donald Davidson's work. I mean, this is classic linguistics. The logical form of action sentences is a classic. Everybody should read this. If you don't like that individual one, there's a whole book by Terence Parsons, which I really love because it's super clear, that talks about actions and processes. Just good stuff. Ontological promiscuity. This has a sort of a cool, flashy name. So you see this all the time. People, and I get arguments like this. This concept must be in SUMO, and must be there as a named entity. And when I can say, for example, firstness, secondness, thirdness. Well, we don't have anything called firstness, secondness, and thirdness. We don't have to create those things. There are other named things that fulfill those roles, I would argue. Right? So things that I ask beginning ontologists to do is, you've got two terms, okay, you've subclassed them from something else. Well, now you've got to state specifically how they're different. Define in an axiom, what are the differentia that distinguish this from that? If they both have the same parent and there's nothing that says how A is different than B, well, then maybe you don't really have A and B in the real world. You just have one thing. If you can't say what distinguishes them, you may have an intuition about what those words mean. You may have different words in the English language, but if you can't define precisely in logic how they're different, they don't deserve to be in there, because logically, therefore, they are the same in your theory. And if people don't pay attention to this, they get a proliferation of terms, which are all mutually, logically indistinguishable, even though they may have different term names. Confusing language and concepts. It's kind of similar. People like to take inspiration from language. Most of the time, that inspiration is good. If you're sloppy about it, it's bad because it can lead you astray, because English and every other natural language has all sorts of problems that's, it's not appropriate as a substitute for a formal theory. Modeling roles as classes. This one's very common. There's more than one way to do this, but I would contend that for things that change over their lifetimes should be modeled as attributes, not as classes and inherent parts of identity. So, I am a speaker right now, and this past weekend I was an electrician, and my roles change over time. And what I don't want to have happen is Adam the electrician, when he ceases to become an electrician, ceases to exist. Right? I don't want my class membership to change. What I want is my attribute to change over time. Right? That it holds during this past weekend I was an electrician, and it holds during right now I'm an ontology lecturer. Very common problem. And of course, you see this actually in WordNet. So we had some interesting discussions about, WordNet has plumber as subclass of human. So Bob the plumber, when he retires, he ceased to exist. Does he change his class membership? No, he's still a human. He's always been a human. He just had a different role that he was playing at a certain portion of his life. Failure to reuse, I think I've talked about. That's a common pitfall, especially since I think there's an inherent bias in programmers. Everybody likes to write their own. I mean, it's just so much more satisfying than learning somebody else's library. It's a pain because inevitably they didn't do it the way you wanted to do it. You know you can write it better, but you can't always do that, right? A lot of times you have to reuse libraries. In fact, all the time we have to reuse libraries. How many people are writing Java code and ignoring all the JDK? If you are, you're probably not writing very good Java code. It's certainly not very reusable. Same thing is true in information design. There are lots of other pitfalls. I'd like to get to the point where I'm talking about how to do modals and normative force and all these other cool topics in ontology. Most people are not even doing this stuff. They're still stuck with the other problems. So I hope we get to this point where we can argue about some of the more interesting stuff. SUMO details. So a taste of what the hierarchy actually looks like. And I'd encourage everybody, go online and browse through it. You got the browser there. It's got lots of nifty tools to help you explore it. You can graph it. You can read the definitions. Even if you don't read the logic, you can read the English. You can read the English paraphrases. Try it. Learn about it. It's fun. High-level distinctions. The top-level node we call entity, the class of all things, real, unreal, imagined, abstract, timeless, occurrence, everything. Entity is decomposed into physical things and abstract things. Physical things have a place in space and time. Abstract things don't. So an abstract thing would be like the number 2. It doesn't have a place in time or space. It just is. And keep in mind that as I talk about the elements in the hierarchy, all these things have formal rules. It's not just a taxonomy. It's not just a set of symbols. It's a set of symbols that have associated formal definitions. Physical things are decomposed into objects and processes. This computer is an object. My talk is a process. Objects further decomposed. We have substances. So the water in this cup is a substance. If I cut it in half, I have 2 instances of water. Objects, if I take that chair and I cut it in half, I don't have 2 instances of chair. I have junk. Right? So difference between a corpuscular object and a substance. Region, a region of space encompassed by the walls of this room, or the collection of people in this room. There are lots of processes in SUMO. This is just the top 2 levels. Processes are very important. This is one of the areas early on in development SUMO I was particularly proud of because, to my knowledge, at the time there was no other formal ontology of processes, at least that was open source and academic. And I think this was an important early development in SUMO. Now it's, of course, much more extensive. Abstract things, so I talked about the number 2. We also have, I like the stuff that I was able to do one year with graphs and graph elements. So I had a company that was actually doing travel planning stuff. And so we already had an abstract ontology of graphs and arcs and nodes and relations and weights. And they wanted to do travel planning, so they actually helped me, motivated me to relate the abstract graph theory to very concrete graph-like things in the real world. So there's this whole nice set of parallels that allows us to reuse graph theoretic axioms in terms of reasoning about road networks and computer networks. Case roles. So we want to talk about the roles that entities play in a particular process. So something's the agent, something is used in the process, some maybe an instrument like this clicker. I'm using this as an instrument in the process of giving this talk. Here's a particular example. So Brutus stabbed Caesar with a knife on Tuesday. So we have a stabbing, so an instance of stabbing, the class stabbing. We have the agent of the stabbing, Brutus. We have the time at which it occurred, the instrument, etc. Useful stuff. This is a Davidsonian approach. I mentioned Davidsonian semantics before. It's the same approach. This is what it looks like logically in terms of the actual axiom that you'd state in SUMO. So there's an instance of a stabbing, an instance of a knife, an instance of a Tuesday, etc. Example rules, again, just hammering home this point about the definition of this term is not your intuition for what driving is, it's this formal axiom and the other axioms that mention this term, so that driving necessarily involves a vehicle. Not terribly exciting. Get a lot of these things together. It is exciting. Language to logic. I have just time to skim this. So we also have a system that's far more experimental that we don't generally release, but if you really want it, I'll give it to you and you can play with it. Just don't expect any support. That translates language into logic. And it's a controlled language, so we translate simple things into logic. So something like Robert has an orange. There exists something. There's a Robert who's a male human. This orange is an instance of orange fruit, and Robert possesses that orange fruit. This is just an alternate notation. I should probably take that out. It just confuses people. Once you have that statement, you can ask a simple query. So who has a fruit? Along with the axiom that says that orange is a subclass of fruit or vegetable. All we need to do is, we don't need a special sparkle. We don't need a special query language. We don't need some other language. We use exactly the same language and just leave a variable unspecified. Okay? So we just leave who unquantified in here. There's nothing that says that what who is, and we need to find a match for it. And if things go right, and we've got a good inference engine, we'll get the match that Robert is the who that matches in this case, along with the proof that specifies that axiom that says that orange is a kind of fruit or vegetable. And this is a logically valid inference. So counterexample. A lot of people have done language to logic stuff, and I want to sort of pick on one hypothetical group of people that do this sort of thing. There are people that do it kind of like the stuff on the right. So if you don't have a large logical theory, it's not so hard to create expressions which look like logic, that use, have stabs and knife and Tuesday and on. But if those terms are not already defined in an ontology, they have no meaning other than the sentences in which they appear. So we might have, Brutus stabbed Caesar with a knife on Tuesday, and Brutus stabbed Caesar on a boat. Where did Brutus stab Caesar on? Right? If on doesn't have any actual meaning, if it's not defined, then you could say it was on Tuesday or on the boat. It's not what you asked for in English, but that English intuition isn't there unless, any number of things, highly polysemous stuff. You've got to do the word sense disambiguation and then have a logical theory that expresses those different sentences so you can reason about them in a way that's consistent with human knowledge. Right? So a lot of people would have this kind of thing, but we have in SUMO this, and each of these terms has a very rich set of formal definitions that governs what it actually means, very explicitly, very formally. So just a few more examples, things like statives. So these are things that are verbs, and they look like they might be actions, but they're really not. So in English, we call them statives. So Dickens writes Oliver Twist in 1837. This is actually a nifty case of where I think we actually have both a stative and a performative. There is an action of writing, of authoring, performed by Dickens, and then there's also this timeless statement, timeless at least after he's done it, true for all time, that Dickens is the author of Oliver Twist, full stop. Not an event, it's just a statement of truth. He'll always be the author of Oliver Twist. Other statements that are stative. So Bob is a pianist, right? So he has this role of being a musician. I think since I made this example, we actually now have pianist in the ontology. Things are changing all the time. We can do counting in this automated system. We can say, Bob kills 5 rats, so there exists a set of this thing. Members of the set are rats, so there's a member count 5, et cetera, et cetera. So some fairly complex things. We can say things like Bob is on the boat, as well as Brutus stabbed Caesar on Tuesday. We have this sort of thing handled, I think, fairly well. So we have the orientation of being on. Party is on Monday. Oh, thank you. Yeah, sorry about it. Is on the boat, not in on the boat. Yeah, it's nonsensical. Party is on Monday. Very different thing. Not an orientation, as it was before, of being on, but rather a during relationship. During sometime on Monday, temporally during. There are lots of different prepositions. We handle a lot of them. And the meaning of those prepositions can change very dramatically based on the types of the arguments that appear around those prepositions. Very different logical forms. There's that one you've seen before. This one I like. So here's an example of how the logical output form, the real deep meaning of this sentence, changes very dramatically based on the types of things stated in the sentence, not on really the predicate, which is just possession. So we have Tom's father is rich, Bob's nose is big, Mary's car is fast. So saying that Tom's father, identifies that there exists a father of Tom, and that father has the attribute of being rich. We have a car. Mary's car is fast. Mary possesses a car. She doesn't have a father in this case. Totally different sort of thing that's being called out here. And if I talk about Bob's nose being big or my nose being big, then we can talk about really a part of relationship. I guess I possess my nose in some sense, but not in the SUMO sense. It's a part of my body, right? Totally different form for the little apostrophe that occurs in each of these sentences. Deep interpretation is a lot harder than just a casual surface interpretation. Negation, along with a particular article, a definite versus an indefinite article. Bob did not write a book. That means there does not there is a book that Bob did not. Bob did not write a book. There does not exist a book that Bob wrote. Bob did not write the book, that book right there. There exists a book, totally different. We're saying there really is a book out there, but Bob didn't write it. Little changes in English, big changes in semantics. And it doesn't like my fonts, but there's my book, and I actually finished. So, thank you.